grocery bags. Still section 10.2, example 5, plastic grocery bags. Do plastic bags from Target or plastic bags from Safeway hold more weight? A group of AP statistics students from first period decided to investigate by filling a random sample of 5 bags. This is an interesting way of doing this. Filling a random sample of 5 bags from each store with common grocery items until the bags ripped. Then they weighed the contents of items in each bag to determine its capacity. Here are the results in grams for Target and for Safeway. Just visually on the surface, it does appear. Who appears to have a larger capacity? Yeah, Target, just by looking at those numbers. But we're going to construct and interpret a 99% confidence interval for the difference in mean capacity of plastic grocery bags from Target and Safeway, and then answer, does our interval provide convincing evidence that there is a difference in the mean capacity among the 2 stores? And the results might surprise you. So, here we are, and we're going to state what we're doing. And so we need to define our variables. So the mean capacity for a Target bag is going to be mu sub t. So you have to say what these things are. Mean capacity of Target bags. We'll just say that, and then let mu sub s equal quotes for Safeway. Same thing, in grams, Safeway. So we have that. And then, so we're going to find the difference of means, mu sub t minus mu sub s, at the 99% confidence level. 99% confidence level. So state is done. Plan. We need to say what the name of what we're doing is. So calculate or perform. You have to say 2 sample t interval. 2 sample t interval for what? For, you would either say the words difference of means, or you would use the symbols mu sub t minus mu sub s. That's our plan. Assuming 3 conditions are met. Number 1, random. Yes, the bags were taken from random samples for each population. 2, normal. We're going to spend some time on this one because the sample size is less than 30. So we have to actually graph the data and look at it. And not only do you have to describe it, you have to show the graph of what you're doing. You have to. So we're going to actually do that. So we will, and you should label what's on each axis. So we can do side by side here for Safeway and Target, and the weight is here, and we'll do weight in thousands. And looking at the numbers that were given, like 12,000, 13,000, the biggest was 14,000, no, 15,000. So we're gonna go by the smallest is 6,000. So we'll do 6,000, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, and then to do, you could just do a dot plot is totally fine. Some of you are doing that. Some of you are doing a histogram, and that's totally fine. let's do a box plot here. So you would to review, you've entered your data in, let's see here, you've entered your data by going to stat and enter for edit, and so your data is in L1 and L2. Indy, will you turn off the other light? I think that makes it easier to see what's on the calculator. So you entered your data into the two lists, L1, L2, then you go to second stat plot, turn it on, and if you go to the one that shows the outliers, then it'll show if there are outliers, there'll be little dots. And then you go to graph, and normally you need to do zoom 9 in order to scale it right, and then you can hit trace so that you can kind of see where the key points are. So you can use that to help you, and then you can go and you should be able to turn on the other one too, or you can just use now L1 instead and do graph, and then zoom 9 and trace so that you know where the key points are on there. So doing that, then you would do something like for Safeway would look like, here are the key points, 8, 10, and around 11, so that, and there. And for Target, something like the minimum is around here, and Q1 is around here, Q2 is around here and here. And so you'll see there are no outliers, and there's no extreme skew going on with those. You have to show it, so then, and describe it. So no obvious skewness or outliers. So there's your normal, and you have to show for both populations. And then independent, of course, you assume the samples are selected independently, and there's at least 50 bags in each store, 10 times 5, the sample size, so independent. And we won't write it, but there. Okay, so yes, it takes a little longer for that, but you have to do that. And remember you have to say the name of the interval too. Okay, here we go, and we'll do it on our calculator as well. So you should not be calculating the mean and standard deviation by hand. That's just a waste of time. Put the data in your calculator, and then go to stat, and then go over to the right to calculate, and then do whatever list your data is in, like L1, and hit enter, and you're gonna pull your mean in S sub x, the sample standard deviation, from there. Do not waste time doing that by hand. So you get these results for the mean of Target. The Target sample is 12,825. You want to list these. The standard deviation of the sample, S sub t, is 1912.5. Average for Safeway is 9234, and standard deviation for Safeway is 1474.2. From your calculator, degrees of freedom are 4, nice. Sample size -1. And then we're going to use the formula. To find T star for our confidence interval, you just do inverse T of 0.005 with 4 degrees of freedom. Why 0.005? Because it's a 99% confidence interval, which means there's 1% left for both tails, which means there's a 0.5%. So in one side, so you want to use, this is 0.5%, 0.005. And that will give you T star, which equals 4.604. And so now we're going to do this on our calculator, but first I'm going to write the formula out, because if you happen to do the wrong thing on your calculator, you will get 0 credit, whereas if you wrote this out, you would get a lot of credit. So using the formula, difference of means plus or minus T star 4.604 square root of, and you can see why we want to start just doing it directly on our calculator, because this gets messier, plus 1912.5 squared over 5. Okay, if you do that correctly, you enter that on your calculator correctly, you should get that the confidence interval is between negative 1380 grams and the difference, and 8564 grams. Okay, so then, so let's do that on our calculator. So you would go to, and we're going to get a more accurate answer on our calculator. So, or, on calculator, do 2 sample T interval, and you will get this. It'll be more precise because it'll use more precise degrees of freedom. You'll get negative 101 to 7285. So it's just a narrower interval. So let's use the calculator to get that answer, and then we'll write the conclusion and answer part B. So you go to, on your calculator, you go to stat, and then scroll over to tests, and go down to the 2 sample T interval. So it's under the test menu, but it's an interval. 2 sample, it's all the way down. Scroll down to number 0, number 10, or whatever, 0. Hit enter. It's that one. 2 sample T interval under tests. Hit enter, and then you are going to, you could hand enter the stats, or just use the data that you already typed into L1 and L2. That's the cool thing. Since we already had to type that data in, I'm going to do data for this, L1, L2. Leave the frequencies the same, confidence level 0.99. Be sure you type that in, or it says that. Pooled is going to be always no for means. And calculate. So you hit enter. And voila. Negative 101 to 7285 roughly. And it tells you what degrees of freedom and the sample mean and standard deviation are there just listed as well, but you don't need it. So now let's do our conclusion in part B. So we conclude that we are 99% confident. We are 99% confident. The interval from, we'll use the one from our calculator, negative 101 to 7285 grams, captures the true difference, in mean capacity of the bags. Mean capacity, you have to put it in context. And finally, for part B, it's plausible that there is no difference in the two means in the actual population. Based on our sample, we had a fairly small sample size. So it's totally possible that there is, in the real population of bags, that there is no difference. Because look at this interval. It includes 0. So we would write, since the interval includes 0, it is plausible there is no difference in the two population means. So, but if we did increase the sample size, we might find evidence otherwise. But with such a small sample size, we really can't be sure.